and return on investment about 17%. Keep in mind for existing houses, the PUC rebate is quite a bit less. It depends where you are in California. If you're in Southern California, the rebate's $1.90 a watt. Again, new homes $2.50 a watt. But in Northern California, most of PG&E, we're down to about $1.10 a watt for your PUC rebate. Okay, I mentioned we're going to talk about the various ways to use electricity to do space heating and domestic hot water. You've got your unitary heat pumps, you've got your geo-exchange, you've got your ductless heat pumps, and you've got your these new air-to-water heat pumps. The basic numbers here, your electric resistance, I want to bring in this term coefficient performance, and it's basically how many watts of electricity it takes to get a watt of heat out of it. So with electric resistance has a COP of 1. You put in 1 watt of electricity, you get 1 watt of heat out of it. A standard air-to-water heat pump like General Electric is producing, you'll have a COP of 2, meaning it's twice as efficient as a straight electric resistance heat pump, and that's till it gets to be about 47 degrees outside, then the COP goes down. Your standard air-to-air heat pumps, which have been sold forever in the United States, especially in the South, your COPs are in about the 3 range. These new air-to-water heat pumps, variable speed inverter air-to-water heat pumps I mentioned in the very beginning, you're looking at COPs that, depending on where you are, on an annual basis can be anywhere into, from about 3 to 4.5. Depending on how mild the temperature is. If you're in an area that doesn't freeze a lot, you can look at a COP sometimes approaching 4. And then the last way to go is geo-exchange heat pumps, which we've been using off and on. We've probably done about 50 homes with geo-exchange heat pumps. The great thing about geo is it doesn't matter how cold it gets outside. You're going to have a COP of somewhere around 4. So in places like Lake Tahoe and other mountainous areas where it gets really cold, geo has some advantages. But these new air-to-waters are so efficient that in most climates in California, the efficiencies are about the same, and you don't have to go through the complexity and the expense of a geo system to have the same efficiency. The first of the air-to-water heat pumps that's coming on the market is made by a manufacturer called Daikin. Daikin is the second largest manufacturer of air conditioning equipment on the planet, next to Carrier, and they're just now coming to North America. This unit, which is called the Altherma, they sell about 50,000 units of these a year in Europe. And what's great about them is, again, high COP using ambient. The COPs are usually good down to about 32 degrees, are usually high, and they get a little bit less from that. These units are efficient, flexible, quiet, and reliable. They've installed 16 of them up in Portland, and I went up to see them earlier this year. Very quiet, and now the downside to these things, one of the features of them, not really a feature, it's just one of the concerns, is the hottest water they'll produce is somewhere around 123 degrees. So when you use it for space heating, be it radiant or fan coils, you got to be very careful with the design, but it's doable. And like I say, they also produce the water for domestic as well as chilled water. They're reversible. So in the summertime, you can reverse it and send chilled water through a fan coil to get cooling and other options. It's a very nice unit. Your conventional heat pumps, again, COPs, usually up to about 3. And again, you have to then match them with an air-to-water heat pump like that. And then you have your geo systems. And geo is very popular in areas that have harsh climate and cheap electric rates. In California, we don't have either. We have high electric rates and mild climates. But with the advent of very inexpensive PV, it's certainly possible to do a net zero energy house with geo, and it's probably a good idea if you're in a place like Lake Tahoe or other places where it's really, really cold. But in most of the mild climates, you're going to see I think you're going to see the air-to-water systems taking over. In general, with the geo systems, you have 2 different types. You have your horizontal beds. To get a ton of air conditioning, you need a 2-foot wide trench, 5 feet deep, and 100 feet long per ton. A ton is 12,000 BTUs. And usually space the trenches about 10 feet apart. More conventionally, you have what we call boreholes, and again, to get a ton of cooling, 5 inches in diameter, and again, spaced at about 10 feet. It's, the systems they're not without their complications. Not many mechanical subs are doing them, but the nice thing about them is they're very quiet outside. The Altherma units are also quiet, but these units are basically silent outside. Okay, one thing to keep in mind is with the air-to-water heat pumps, if you do have floor heating, you are limited to about 123 degrees, and therefore the aluminum-based floor heating systems, warm board, EcoWarm, thermal board, will work a lot better than your Gypcrete systems, and certainly a lot better than joist heating systems. We're trying to go underneath the subfloor. Those are going to be very difficult to match with these air-to-water heat pumps. Okay, I have several case studies for you. And I think you'll see that I've done 100 projects in '09. We hope to do at least another 100 this year, and various of all different styles. And the nice thing is that about 50 of those are under construction, and at least 25 of them should be done in the first quarter of 10 or of 10. All right, the first house is a house in Santa Barbara, 2,948 square feet. All of his appliances were Energy Star. The guy wasn't a big fan of LED or fluorescent lights, so only 25% of his lights were high efficacy. The rest were incandescent. Wasn't a particularly well-insulated house. R19 ceiling, and I can't remember if it was R2x6 or 2x4 walls. He did buy very good Energy Star windows. Didn't pay extra for them, but did get nice Energy Star windows. He was putting in an air-to-water heat pump. The size of the system required to do the entire house, 7.3 kilowatts. The system was going to take up 412 square feet of roof, and the after-incentive cost was $20,000. Added to his mortgage, $113. The standard operating for this house, we moved without the solar and just with just a standard house in Santa Barbara this size, would use $289 a month of energy. Keep in mind you have to make about $400 to pay the utility company $289, so he's saving $250, $300 a month right off the bat. His dollar savings per year, his after-tax savings were $4,600. So his payback a little under about 5 years. The other thing in savings, people are very concerned about the CO2 gaseous, the carbon dioxide gaseous emissions. This house over a conventional house, same size, built in Santa Barbara, will save 10,146 pounds of carbon dioxide gaseous emissions per year. Now, and that's with his $20,000 investment. So let's say the guy went ahead and bought a slightly used Prius for $20,000. He would save 3,000 pounds of carbon dioxide gaseous emissions per year, assuming he drove the car 10,000 miles, and would save about $400 a month in gas charges, gasoline charges. So by putting his money into making his house net zero energy, he's saving 3 times as much carbon dioxide gaseous emissions and almost 11 times as much money. In our business, we sell construction. We don't sell cars, and yet about 100,000 Priuses were sold in California last year. So that once the homeowners understand that their money goes a lot further in making their house energy efficient than buying an energy efficient car. Not that they shouldn't buy an energy efficient car. It's just the numbers come out a lot better. I've got case studies. We're now up to 100 in our database that can be seen on our website, netzeroenergycertified.com. But these are just similar projects. The first house we did was a house in Petaluma, and it was really made a huge impression on us, was just how cost-effective the system was. Really, the bigger the house, the more cost-effective the systems are. But I've got case studies you can take a look at on the website. This last project we did was an 8,200 square foot house in Carmel Valley, a nice big house, but the cost avoidance, he's going to spend to add this system to his mortgage is going to cost him $338 a month to be net zero energy, 20 kilowatt system, big system, and he's going to save. His standard operating cost for a house is